Let me introduce myself. My name is Muhammad Azam bin Shaidi. My matric number is AE180037. I am supervised by Dr. Hafizah binti Ngajikin. Today, I will explain my final year project 2 for session 2021-2022. The title of my FYP is an IoT-based temperature monitoring system for transformer application. For introduction part, power transformers are designed to operate reliably and effectively for many years. All immersed transformers are the key to measure through its properties and play an important role in ensuring the reliable function of the transformer. The lifetime of the operational reliability of the oil transformer decomposed due to temperature increasing in the winding led to accelerated aging and can signal a breakdown in oscillation or indicate a fault condition. With the help of the IoT technology, the monitoring transformer oil temperature could be monitored remotely by designing an online data with secure accessibility. The module then connects to the specific Ethernet ID to begin sensor data to IoT server. The problem statement of this project is the lifetime of the oil transformer decomposed due to its temperature increasing in the winding. Development of the monitoring sensor need to detect the temperature status so that it will decrease of manpower and increasing the stability, accuracy and the performance of the transformer. The hypothesis of this project is the temperature is one of the most important aspects that might influence the lifespan of the transformer. An increase in temperature in the primary contributor to a shorter lifespan for a transformer as well as the breakdown of its insulation. The end of the project is the main purpose of this research to characterize and integrate an IoT-based system with transformer oil temperature prototype. An IoT-based embedded system that utilizes a microcontroller and a temperature sensor is represented in order to remotely monitor transformer parameters such as oil temperature. Oil transformer. There are three objectives in this project. The first one, to develop of IoT-based transformer oil temperature monitoring system with DS18B20 waterproof temperature sensor. The second one is to perform sample of the transformer oil temperature by using real-time data remotely over a Wi-Fi module to the IoT device. The third objective is to determine the percentage error and the stability precision of the oil transformer temperature reading from the 34 degrees Celsius and to 76 degrees Celsius. The scope of work consists of three parts. Scope 1 will cover the temperature sensor employed is DS18B20 type and will be integrated with the IoT monitoring system. .mcu will be used to track the output of the temperature sensor and process the data to the IoT platform for the monitoring system. The third scope is .mcu and the sensor module will be connected to the ThinkSpeed server that support the IoT technology in transformer oil monitoring system. In this project, the monitoring system consists of three main units including input, process and the output. The input part is the temperature sensor we receive data and transfer to .mcu for processing. For the process part, a power supply is connected to the .mcu and the .mcu is used to develop as a microcontroller unit and function as a Wi-Fi module in the system. And the output, the ThinkSpeed as IoT-based applies for monitoring the transformer oil temperature. The data is uploaded to the MCU module for it be run as designed and uploaded data to the ThinkSpeed. There are three steps has been done for complete to this project. The phase 1 is about the study of the temperature sensor for power transformer application. The DS18B20 sensor was chosen because it is waterproof so that it's suitable with my project because the sensor will be submerged into the transformer oil to measure the temperature. The phase 2 is about the development and the characterization of the system with IoT. The complete circuit had been designed to detect the temperature of the transformer oil. The Arduino IDE used to interface the DS18B20 sensor with programming code so that the sensor identifies the reading of the temperature. Then the IoT system was developed to easily collect the temperature data. For the phase 3, we'll be focused on the integrating or combining each sensor and the IoT device. The temperature sensor measurement data will be sent to the ThinkSpeed platform. Okay, this is the figure of my project. The above figure on the left side shows the IoT module that has been done in this project. It consists of .mcu microprocessor, 4.7 kilo ohm resistor and the DS18B20 temperature sensor. And the figure on below left side show the hardware testing and troubleshoot with the ThinkSpeak interface. The data from the sensor will be sent out to the ThinkView on my phone device. And the figure on the right side show the experiment setup. It consists of a transformer oil in the beaker, the IoT module, thermometer and hot plate to heat the transformer oil. This is the result for comparison data of digital thermometer and the DS18B20 temperature sensor. As we can see here, the parameter of both reading are significant. This result will collect during testing and troubleshoot sensor in optoelectronic laboratory at QB Building FKEE. The percentage error will calculate by this formula. The percentage error will be analysed in the graph later. And the next table shows the temperature and the current to calculate its stability precision. The current will measure by tapping the ground wire and the data wire and measure its current by using multimeter. The formula used to calculate the stability of the sensor by using this formula. Those data that have been collected has been produced into the graph. The first graph shows the accuracy performance of the system. Okay, the error is 5.5% at 50 degrees Celsius. The result is higher at temperature 40 degrees Celsius because the starting point of the temperature value rise during the experiment. At temperature ranging from 49 degrees Celsius to 50 degrees Celsius, the percentage error is sustained, and the percentage error is 1.41% at 74 degrees Celsius. The second graph shows the stability of the measurement. The output current measured every 2 minutes for 2022 sample. The range of the output current in between 0.75 mA to 0.77 milliampere observation. The average output current is 0.7577 milliampere and the stability of the temperature sensor is 99.59%. This indicating that the temperature sensor are very stable with the measurement error of 1.41%. Okay, now we move to the IoT characterization. This is the Arduino IDE programming code for measuring the transformer oil temperature. The first part show the command used to declare coding and the sensor libraries. The second part, the command used to set up API key and the Wi-Fi coding according to the system. The third part show the command for receiving data from sensor and display the value of the data. The next is the command used to alert the failure of the sensor. Then this part show the command used to send the sensor data to TeamSpeak. And the last part is the command delay used in Arduino IDE programming. This is the figure of IoT part that have been done in my project. Arduino IDE was used for connecting the network and sending sensor data to the user via the TeamSpeak server. And the figure below on the left show the API key was inserted to the coding to link the sensor and the TeamSpeak interface. So the API that have been appear here, I will insert into the coding to interface the TeamSpeak and the sensor. The data of oil transformer measured by DS18B20 sensor are uploaded to the TeamSpeak website and displayed in the graph. The data that has been sent to the TeamSpeak are tally with the real time. This is why it's called a real-time monitoring system for measurement of transformer oil. Other than website, the monitoring can be displayed on the right side of the slide in smartphone. So that is the TeamView. TeamView can be downloaded from the Android phone or iOS phone. For the conclusion part, a system for monitoring the temperature of transformer oil that is based on the IoT has been devised, deployed and tested. The system has been outfitted with a TeamSpeak interface so that the data collected from the temperature sensor is able to view on smartphone or the computer. The percentage error and the precision stability of a purpose temperature sensor has been determined in this project. The DS18B20 waterproof temperature sensor can be used as an IoT parameter to measure the temperature of the transformer oil because the temperature sensor are very stable in my project. So that's all from me. Thank you.